In this video, I will explain how to calculate probabilities using Microsoft Excel and RStudio. There are two types of variables, discrete variable and continuous variable. For discrete variable, we will have there are four types of probabilities, but we will discuss only binomial and Poisson probability. And in continuous variable, we will discuss uniform probability distribution, normal probability distribution, and exponential probability distribution. So we start with binomial probability distribution. In binomial probability, there are four conditions that must be met before a probability problem can be considered as binomial. As the name suggests, binomial, which means two nominal outcome. So in this type of probability, we will have two outcomes. For example, one could be success or failure, yes or no. Uh, if a customer makes a purchase or doesn't make a purchase, head or tail, like that. Or someone boycotts a survey, or someone boycotts a product or does not boycott a product. Or there is a military system for detecting missile attack. Does it detect a missile attack or it fails to detect a missile attack? And these four conditions are that there are multiple trials. So for example, let's say if you have a coin, you flip it multiple times. Every time you flip a coin, it will be considered as a separate trial, and two outcomes are possible. For example, in case of flipping a coin, a head or a tail, the probabilities of two outcomes do not change from one trial to another one. If you flip a coin one time, the probability of getting head or tail is 50%. If you do it second time, if you flip it second time, the probability again remains the same, that's 50%. Third time, fourth time, fifth time, every time the probability would remain same, that's 50% for either head or tail. And the last thing is that these trials are independent and they are not influencing each other. So for instance, again in this case of flipping a coin multiple times, every time you flip a coin, it does not has any bearing on the forthcoming or on the previous trials. When these conditions are met, we call it binomial probability. This is one problem of binomial probability. It says a survey of British social attitude asked respondents if they had ever boycotted goods for ethical reason, and the survey found 23% of the respondents have boycotted goods for ethical reasons. So 23% is the probability. In a sample of 6 British citizens, what's the probability that 2 have ever boycotted goods for ethical reason? Now, if we put this question on the criteria for binomial probability, you will see that this successfully qualifies as a binomial problem. There are total 6 citizens, and the question is, of course, they are like independent. Their decision to boycott a product or not boycott, that's totally independent of each other, which means they are not like communicating with each other, or at least that's assumption. And probability also remains same for all of them. And then so that's the total number is 6 British citizens, and we are interested in the probability that 2 have ever boycotted goods for ethical reason. I have converted that problem into this table in Microsoft Excel, where we will be calculating binomial probability, and 0.23 or 23%, that's the probability, and then n is number of that's the number in which we are interested, and x is the total number. So in this problem, x is 2, n is 6, which means we are interested in two outcomes in 6 trials with a probability of 23, which means what's the probability that 2 of them have boycotted a product for ethical reason when we do this experiment, collect data survey from using 6 citizens, and the probability is 23%. And in Excel we will use this function that's called binomial distribution, binom distribution, and then first x, and then number of trials, and then probability. And the last thing is that it's asking cumulative or not. So in this case, we are interested specifically in two outcomes only. So which means it's false. If we are interested in less than two, including 0 and 1 and 2, then in that case we will write here cumulative true. But since in this case we are interested only in two outcomes, so therefore we will write false. And that gives a probability of 0.2789. Okay, in the next question it says what's the probability that at least two respondents have boycotted for ethical reason. Now one thing important here is that it's at least two, not two, which means we cannot choose the value of 2, but it means like 2 or greater than 2, which means it can be anything 2, 3, 4, 5, 6, but at least 2. And for this purpose we will use another function. To solve this problem, what we will do is that we know that the total probability is 100% or 1. So what we will do is that we will calculate the cumulative probability of 0 and 1, and then we will subtract it from 1. 1, that's the total probability, and that will give us probability of 2 and above. So for that one we can say is equal to 1, that is the total probability of any system, and then here binomial distribution, and then I will write here 1, and then 6, that's the total number of experiment, and then 0.23, and then cumulative, that's true. Now in this syntax I used here 1 rather than 2 because I am calculating cumulative probability, and cumulative probability means that it will give me answer from it will give me a cumulative probability of 0 and 1, and then I can subtract that from 1 minus probability of 0 and 1, and that will give us probability of 2, and then greater than that. So that gives us probability of 0.41 or 41.8%. In the last part it says in a sample of 10 British citizens what's the probability that none have boycotted goods for ethical reason. Now over here n is 10 and none x will be 0, and for this purpose we will use is equal to binomial distribution, and then 0, that's we are interested in 0 outcomes, and total number is 10 in this question, and probability is 0.23. And is it cumulative? No, because we are interested only in 0, not anything less than that, so we'll say false. And that gives probability of 0.073 or 7.3%. I would like to spend a little bit more time on this cumulative and false in syntax of binomial probability. So for instance in this one that was probability of 2, and we used false because it was specifically the probability of 2. But let's say if we use true here instead of false, then it will give us probability of less than 2 and less than 2, which means probability of 0, 1 and 2. So let's see first is equal to binom distribution. So when I use this true, it gives me a probability of 86%. Now let's manually calculate probability of 0, 1 and 2, and then we can add them together and see if our answer comes this one, then it would mean this is okay. So let's say for instance I use the same thing, binom distribution, and 0 and then 6, probability is 0.23, and then I will use false because it's only probability of 0. So this is the probability of 0, and this one I will change from 0 to 1, and this one I will change to 2. Now this is probability of 0, probability of 1, and probability of 2. The value of n and p, they remain same, only the value of n is changing. N is 0, 1 and 2, and if we add them together, then we get 0.86089, which is exactly the same thing. So I just wanted to explain the whole idea of this cumulative function. I used here cumulative function. In this one, that was the first part of our problem. It was only about a probability of 2, so we used false function. And this was a hypothetical scenario in which I just wanted to show that what does cumulative probability would mean when we use 2. It would mean that the probability of 0, 1 and 2, or everything less than 2, and then we also did it manually, and we see we get the same answers. The next is doing binomial probability on R. In RStudio, we will use this function. It's called dbinom, and I'll be using the same data that we saw in the problem, and also we did on Excel. And there were 2 outcomes that we were interested, and there were total 6 trials or 6 people, and the probability of boycotting was 23. Now in these type of cases, when you are specifically interested in only the probability of one given outcome, that's 2 in this case, in that case we will use this d binom, that's a distribution binomial, and when I run this command, it says that it's 0.27, and that's exactly 0.27 that we also found in Microsoft Excel. Then in RStudio, there's another thing that's called p binom. So this was d for distribution and p for probability, let's say. And in p binom, that's meant for cumulative probability. And in, for example, let's say I have this command that's a p binom, that's cumulative probability of 1, 6 and 0.23. If I run this, it will give me a cumulative probability of 0 and 1, and for example, when I run this command, it will give me this probability of 0.58, and you can also mention their cumulative true. By default it will give a cumulative one even if you don't mention true, but even if you mention true, it will give the same results at 0.58, again the same thing. However, if you mention false, then it will give you the probability of the other side, the right side, which means the probability of 3, 4 and 5, 6 together. And let's say, for example, this one was cumulative probability of 2 is let me run it, let me clear this one. This one probability is 0.86, and when I run this one, then that is 0.13, and the total is equal to 1. I would like to repeat it before we wind up and move to next topic. In binomial probability, there are 3 important things. One thing is d binom, that's distribution, binomial distribution, that gives the probability of that specific outcome. So this one will give only a probability of 2. And then in cumulative probability, we have 2 sub aspects. One is one is true and a false, and when we use true, that it gives cumulative probability, which means that's on the left side. So for instance, this one, it will give probability, it give us probability of 86%, which means it's a probability of 0, 1 and 2 together. That's 86%, and that's exactly the same thing that we had also calculated earlier in Microsoft Excel. And when we mention here false, it means we are talking about the upper tail. Then in that case, it would give probability of greater than 2, which means 3, 4, 5 and 6. So if we use this formula D binom, and I substitute here 3 and then 4, 5 and 6, and then I add them all together, they will be 0.1391, and these two things, a p binom true and false, the total probability becomes 1. And this is something that's slightly different from Microsoft Excel. In Microsoft Excel, when over here, like we are using the same number, 2 using here and 2 using here, and over here it would mean that everything less than 2 including 2, and this one means more than 2, 3, 4, 5 and 6. The next type of probability for discrete variables is Poisson probability. In Poisson probability, we are interested in number of occurrences over an interval, and that interval could be time or it could be length. So for instance, number of patients who arrive at a healthcare clinic in 1 hour. So that 1 hour, there are two things here. That one thing is interval, that this is time interval, and the other thing is number of occurrences, and that's number of patients that we are interested in, or number of cars that arrive in the driveway of a restaurant, or the number of cars that arrive at a gas station in 5 minutes, number of computer server failures in a month. So this is interval, and these are occurrences in which we are interested. Number of repairs needed in 10 miles of highway. Now this is physical interval. The earlier one were time interval. This is physical interval. Number of patches or potholes in a highway, 10 miles of highway, number of leaks in 100 miles of pipeline, or number of blemishes in 1 meter of cloth. So all these are examples of binomial probability. This is an example of Poisson probability. Telephone calls arrive at the rate of 48 per hour at the reservation desk for regional airways. Find the probability of receiving 3 calls in a 5-minute interval. So as you can see that this question perfectly fits the frame of a Poisson probability, that there is interval that's given, and then we are interested in number of occurrences, that's calls within that interval. And what happens is that we are usually given some mean upfront. So for instance, over here the mean is that arrive at the rate of 48 calls per hour. And one of the precaution that's needed in these type of questions is that there may be different units. So for example, over here mean is given per hour, which means 48 calls arrive per hour, and then all questions are about a minute, 5 minute, and then 15 minute, like that. So for this purpose, we need to make these unit or this interval same, because we will be using these both. So this interval time unit and this one, they should be same. So what we do is that if we calculate this one, we can say it will be 48 calls per 60 minute, and that's roughly equal to 48 divided by 60 is equal to 0.8 calls per minute. And with that perspective, 5 minute 5 multiplied by 0.8 should be equal to 4 calls. So which means when we will be solving this question, this part, it will be mean will be 4 calls, and we are interested in getting the probability of 3 calls when mean is 4 calls. That comes from here within a period of 5 minute interval. So first we will do it on Excel. In Microsoft Excel, I'll be using 3 columns. One is about a revised lambda, and other is number of occurrences in which we are interested, and then we'll be calculating probability. And this column, that's a revised lambda, that's about like congruence between the mean given in the top statement and in subsequent questions. So for instance, in this case, find the probability of receiving 3 calls in a 5 minute interval. We had determined over here that if 48 calls arrive in 60 minutes, then in 1 minute 0.8 calls will come, and in 5 minutes 0.8 multiplied by 5 is equal to 4. So in this question we'll be using 4 as average, and we will use this Poisson, Poisson distribution, and then it says number of occurrences 4, and number of occurrences in which we are interested is 3, and mean is 4. And is it cumulative? No, it's not cumulative, but it's just a probability of 1. So as you can see that in suggestion it says X, that's the number of occurrences which we are interested, that's 3, and then it says mean, the next is mean, so and mean we know is 4, and then the next suggestion is cumulative. No, it's not cumulative, false, and that gives probability of 0.1953 or 19.5. The next part is find the probability of receiving 10 calls in 15 minutes. Now, as we had already determined that it's 0.8 calls per minute, and 0.8 multiplied by 15, it will be 12. So in this question, mean will be 12, and number of occurrences is 10. So it's equal to, and first thing is X, it is 10, and mean is 12, and of course it's false, and that gives probability of 10.48%. In the last part of this problem, it says if no calls are currently being processed, what's the probability that the agent can take 3 minutes for personal time without being interrupted, which means that 0 calls without being interrupted, no call coming, 0 occurrences, and 3 minutes. 3 multiplied by 8 is 2.4, and so here number of occurrences X is 0, and mean will be 2.4, that is 0.8 multiplied by 3, and then it's false, which means we are only interested in 0, and that gives probability of 9.07%. To calculate Poisson probability in RStudio, we'll be using 2 functions. One is D Poisson and P Poisson. So let's say let's start with D Poisson. In D Poisson, let's say we start with the same problem that we had earlier. We also solved in Microsoft Excel. We are interested in 3 outcomes, and average is 4. And if I run this command, and that gives us a 0.195 probability. That's exactly the same we got in Microsoft Excel. And then the next one is, let's say we are interested in 10 outcomes when the mean is 12, and when I run this command it gives 0.104, and again that's exactly the same. And the last one was we are interested that no phone call comes in 3 minutes, which was in that case 3 multiplied by 8, it was like 2.4 when the mean rate is 2.4, and in that case it is 0.0907, so which again is the same. So this de-Poisson function is used when we are interested in calculating the probability of a specific number. And the next thing is that, as we also discussed earlier, whenever we are interested in calculating cumulative probability, then we use this p Poisson function. So for example, let's say in p Poisson I use this number 3 and 4, and when I run this command, that gives me cumulative probability of 0.4334, which means the probability of 0, 1, 2 and 3 together. Now we can also confirm it, and to confirm it, that if I run the probability of 0, 1, 2 and 3 when mean remains 4, and I add them together, would it give me the same result? Now for this purpose I will run this command where I have 0, 1, 2 and 3 and everything remains same. So you see here we have this one with 0, it's 0.018, 1 and 2 and 3, and if you add them together, that will be 0.4334, which will be the same. So if I have to repeat all these things in Poisson probability, we would say that in Poisson probability we have two things. One thing is a Poisson or Poisson distribution that is used when we are interested in calculating the probability of a specific number occurrence. However, when we are interested in cumulative probability, then we use a p Poisson function. The next probability is uniform distribution, and uniform distribution, it applies of course with a continuous variable, and it's a situation when there's a probability that some number is there's a uniform probability that it's uniformly distributed here. Further theoretical details can be found in the book, and in Microsoft Excel, or let's first see an example. Here's an example. It's a question number 19. It says that Delta Airline quotes a flight time of 2 hours and 5 minutes, which means 125 minutes for a particular flight. Suppose we believe that the actual flight time are uniformly distributed between 2 hours and 2 hours and 20 minutes, which means they are distributed between 120 and 140 hours. And if we could make a graph of this one, that will be the graph that from 120 to 140, and the probability that a flight is uniformly distributed between these two limits. And the first question is that show the graph of probability density function. This is the graph of probability density function, and then what is the probability that the flight will be no more than 5 minutes late, 5 minutes late from the stated time. That's the time told to customers. So the time that's mentioned on the ticket is 125 minutes, and no more than 5 minutes, so 125 plus 5, that's 130. So what's the probability that the flight will be no more than 5 minutes late, which means it will be less than 130 minutes late. So which means that what's the probability that it will fall within this region from 120 to 130. When we do it manually, what we do is that first of all we calculate this range, what's the difference between 120 and 140, that's 20, and then we calculate the height, that is the inverse of this width. So this width is 20 and the height will become 1 over 20, and that becomes the whole area. And then we will see where is our point of our interest, and then accordingly we calculate that area. So for instance, in this case, here is our point of interest and we are interested in this area between 120 and 130, that the flight is no more than 5 minutes late, which means it's less than 130, which means it ranges from 120 to 130. And this distance from 120 to 130 is 10 multiplied by 1 over 20, that's a height, and that will be 50% or zero point 0.5, that will be the probability. And the same thing is also used here in developing a formula. There is no one syntax for uniform, so what we do is that we say here minimum value in the range, that's 120, maximum value in the range, that's 140. This one, minimum value for our interest, that's 120, because we have to calculate distance from 120, and the maximum value for our interest is 130. So these are two values of our interest, because these are the values in which we have to find our area, that's 120 and 130. So which means if we could find this area, please note the movement of this cursor. If we could find the area of this region, that will be the probability. And for this purpose, what we do is that we use this thing, this syntax, that's d6 minus d5, and I can d6 minus d5, and here is this is d6 minus d5. So first we take this couple, and we take the difference and then divided by the difference of this upper couple, that's a difference of 120 and 140, and then dividing them, and that gives the area. So over here it will be 50%. And let's say the next question is that what's the probability that the flight will be, we just stated, what's the probability that the flight will be more than 10 minutes late? Okay, the quoted time is 125, and then adding 10 minutes it will be 135, more than 135. So which means that, let's say, suppose if this is 135 and then we are interested in this area now. So suppose this is 135 and we are interested in this region. And for that purpose, what we do is that our minimum value in the range remains same, maximum value remains same, minimum value of our interest will become 35 and the upper value will become 140. So minimum value of our interest is 135 and the maximum value of our interest is 145, and then just using the same formula, that gives probability of 25%, which means there's a 25% probability that the flight will be more than 10 minutes late from the quoted time. So this is how we do a uniform probability distribution in Microsoft Excel. In RStudio, we calculate uniform probability distribution by using this syntax, that's punif, and over here default is that it will give lower tail is equal to true. By default it will give lower tail, but if you want upper tail, then you have to specify false. So for example, in this case here that's 130 is the value of our interest, and the range is 120 and 140. If I run this one, it will give me this distance, this area from 120 to 130, that's a lower one, so that's a default in this one. And I run this command and that gives us 50%, 0.5, that's exactly the same that we had calculated earlier. And if we want to find the upper one, so no, in this case it's 135, and when I run this command, that will give a 25%. Again, that's the same thing that we found in Excel. And if I use this function, that's 135 and then range. And if I do not mention here anything true or false, then default is that true, which means it's asking for cumulative one. In that case, it will give us this area. If this is 135 and on the left end from 120 to 135, the whole area that represents probability that will be given, uh, which I can imagine will be about 0.75 or 75%, because this is 50%, and then 135 here, that will be another 25%, so that will be 75%. So when I run this command, that gives 75%. That's a probability that the flight will be between 120 and 135 minutes late. If I summarize everything, a uniform distribution in RStudio is done by using punif syntax, and the default function is that it will give lower tail, which means you don't need to even specify here. That will be the default one. However, if you want probability for the upper tail or the upper end, then you need to specify here false.